So we're venturing off into the world of matrices, and we're going to begin with the most obvious of basic questions. What is a matrix? Yeah, exactly. What is a matrix? Okay. It is a movie. Yeah, it's a movie. But okay, in terms of math class for us, what is a matrix? Anybody know? I know you've had these before. It's close. It's related to a system. Absolutely. Okay, so I'm looking for a few keywords, and here's the keywords that we're going to use, okay? So the definition for us that we're going to use and build from is this. A rectangular array, A-R-R-A-Y, a rectangular array of numbers arranged in rows and columns. Okay, that's what it is, and they are used for many purposes, but the one that we're going to work with, they're used for solving systems, and that's how they're related to systems, and that's why we study systems first, and then we move on to matrices. So a matrix for us, to review, is a rectangular array of numbers arranged in rows and columns used to solve systems. And the cool thing about matrices is that the system can be as big as it wants to be. Matrices can handle it. So that's one really strong application for matrices. All right, the first thing that we need to learn how to do is to take a system and turn it into a matrix. But we also want to be cognizant of the fact that we could take a matrix and turn it back into a system. So I have this double arrow between the two, meaning that I could take a system and make a matrix, or I can take a matrix and make a system. Both ways, it goes both ways, okay? So let me start off by giving you guys a typical system, all right? So the system could be 3x plus 5y minus 10z, and that's worth 15. Negative 2x minus 3y plus 4z, and that is worth negative 5. And then I could just say that 10y minus 2z's is worth 11, okay? This is our system, and we have been very good about learning about systems and solving systems using addition and substitution and elimination. We've graphed systems and so on and so forth. Okay, I want to take this system and I want to turn it into a matrix. But not just any matrix, it's what's known as an augmented matrix. A-U-G-M-E-N-T-E-D, an augmented matrix. Okay, so how do we accomplish this? The first thing we do is we draw big brackets to enclose the entire matrix. So it's customary for the notation for matrices to use big giant brackets that face inwards, okay? And just like in the system, we have a bunch of coefficients, and the coefficients are these numbers that are on the outside of our variables, and then we have some constants on the right hand side. So we have some separation between constants and coefficients. That's how we create the matrix. So this matrix would be consisted of a 3, a 5, a negative 10, and then we draw a line down the middle that doesn't go beyond the bars, and then we have a 15. So there's still that same separation of like the equal sign for constants and coefficients in the system as in the matrix. So what would the second line of a rectangular array of numbers be? Negative 2, negative 3, 4, and negative 5. Okay, what about that third line there? There's no x value. What do we do? Yeah, we plug in a 0 into the matrix. Because I could represent this as 0x, right? So the 0 is the number out in front. That's my coefficient. That goes into the matrix. And then this would be a 10, and then a negative 2, and then finally an 11, okay? So there we go. We've taken a system, and we have now created an augmented matrix. Is that pretty straightforward so far? Okay, now let's just move over and talk about an augmented matrix just for a moment here. The first thing that we talk about is the way to describe this. And the way that you describe a matrix is by its order. So the order of this matrix is a 3 by 4. What do you think I mean by a 3 by 4? Yeah, remember the definition says a rectangular array of numbers arranged in rows and columns, right? So there are 3 rows in this particular matrix, and here are the 3 rows. Here's your first row, everything right there. Here's your second row, and here is your third row. Rows go left and right. I kind of think of like dresser drawers, like top drawers, socks, middle drawers, like shirts, bottom drawers, like shorts or something like that. They go top to bottom, right? So it always goes rows by, and then the 4 is the columns. So I'll do that in green for you. This is column 1, this is column 2, this represents column 3, this represents column 4. So the 4 part represents the columns. And it will always be that. It always goes rows first and then columns, and we call that the order of a matrix. So if I was talking with you and said, oh, I have a matrix of order 7 by 8, what am I talking about? 7 rows by 8 columns, okay? Now, we can get even more specific, okay? We can talk about every single specific entry in the matrix, okay? So as an example for right now, if I were to focus on like the number -2, or the number 11, or the number -3, or the number 15, each one of these individual numbers, these are called entries. Okay? And how many total entries do I have in this particular case? I've got 12, 3 by 4, 3 times 4. That will tell me total number of entries, okay? Now there's a notation that we can use to describe specific entries in a matrix, and it goes like this. A, M, N. What do you think I mean by A, M, N? The M and the N represent the rows and the column. Rows and column. So that's your row and that's your column. So for an example, if I wanted to talk about a specific entry 31, that does not mean A sub 31. That does not mean, I don't know what else it could mean, but it means entry in row 3, column 1. So what number is in row 3, column 1? Yeah, this is the entry 0. You guys see that? Okay, what would be this one? A24. What's in the second row, 4th column? -5. Does everyone see that that's -5? Second row, 4th column. So we just have, it's basically a little tiny map that tells you which entry to look at, okay? Okay, I'm going to circle an entry, and you guys tell me how to describe it, okay? I'm going to circle this one right here in blue. How would I describe this entry? A sub what? 2, 3. Second row, 3rd column. You guys get that? No big deal, right? Okay, let's talk about special parts or special form of a matrix. Take a look at this matrix. What is the order of the matrix I just wrote down for you? What's the order? No, rows by column. How many rows? 3 by 4. Nice job. Okay, everybody else. This is a 3 by 4. Easy enough. Okay, fair enough. Now, do you notice anything special about this particular matrix, the way it looks? Yeah, cool. Okay, there are these zeros here, and I call this the golden triangle on the lower left-hand side. These are all worth zeros. You guys see that? Okay, it's coming back to you, right? What else? There's also something else that's kind of really important about this particular form of a matrix. What else is important? There are these ones that appear right here. There are all these ones that appear right here, right? Okay, this part of the matrix that I'm going to put a box around, this part of the matrix right there, that is called the main diagonal. Now, don't forget what a matrix is used for. What is it used for? To solve a system. Now, this matrix is already put into matrix form, right? It came from a system. What is one really nice piece of information that I know about the system that this matrix came from? That's it. That's it. Keep going. What is it? Z is 9. How do I know that Z is 9? Because it's the last one, right? That's what's so nice about having that 1 there. Well, if there are 1s in the main diagonal, and there are zeros in the lower golden triangular region, like I have here, this is a certain type of a form of a matrix. And this form is called REF. Do you remember what REF stands for? Okay, I'll tell you. It stands for row, echelon, from the person who figured it out, form. Okay? Row echelon form. Row echelon form is very, very nice. The reason that row echelon form is very, very nice is because now it tells me right away that the z value is worth 9. And if I know the z value is worth 9, then I can start back substituting into row 2 and figure out that 1y plus 2 times 9 is equal to negative 4. And then I could figure out what y is. And then I could back substitute again into row number 1 and figure out that 1x plus 5y's plus 7z's is worth 3. And I could figure out the values of x, y, and z. And essentially, I could solve the matrix, which is essentially solving the system. Does that make sense how it all fits together? Okay, so this is called row echelon form. This is our goal. Our goal is to be able to get here by hand and back substitute, but there are some nifty little parlor tricks that the calculator can do that I'm going to show you to help you out along the way, okay? We have two goals. We have a couple of goals for this particular section. One goal is to understand what a matrix is and what it's used for. Another goal is to be able to take a system and turn it into a matrix and vice versa. Third goal is to be able to put any matrix in row echelon form and solve. And the fourth goal is to have mad calculator skills, okay? That's what we're going to do right now. I'm going to show you the third and fourth ones kind of on the end here. But I want to explain to you what REF meant and what it looks like, okay? So as an example, is this matrix in row echelon form? Row echelon form or not? No, why not? Because this needs to be a what? It needs to be a 1. Very good. If that was a 1, then it would be in row echelon form. Okay. Now, box number 4 is fun calculator demo. So you need to take your calculators out for now, okay? So let's we're going to do a calculator demonstration, start to finish, tie all this together. I've given you a system. Let's create the augmented matrix here. You guys just spit it out really quick. Let's write it down. What is it? 3, 1, 2, 31, 1, 1, 2, 19, 1, 3, 2, 25. Okay, good. What's the order of this matrix? This is a 3 by 4. Good. I'm going to move it all the way to here so we have room to work, okay? Now, is this matrix in row echelon form? No. No, why not? We have no zeros in the lower golden triangle, and we have not all ones in the main diagonal, okay? All right, good. Now we're going to actually bring in some technology and bring in some calculator stuff. So take your calculator out and move it over here so that we can all see what's going on, all right? Please follow along in the calculator and do this with me because this is a calculator skill that I want you to be able to have. And I will have you do some questions that only involve calculators, so you need to know how to navigate through the system, okay? So from the home screen here, we're going to hit second, and then this x negative 1, which says matrix because it's written in blue. Okay, second matrix. So here's your introduction. Here's your introduction to the matrix folder. In the matrix folder, you have 3 tabs. You have the names, you have the math tab, and you have the edit tab. Okay? Underneath the names tab, the calculator has matrix A, B, C, D, blah, 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 all the way down. Those are the names that the calculator gives to a matrix, and that's okay. You can't change it, so don't worry about it, okay? And if you go over to the right and push math, you have a bunch of different mathematical operations that you can do with a matrix, some of which we're going to actually do today. Then if you go over to the edit button one more time, you can edit matrix A, matrix B, matrix C, and blah, 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 blah. So what we're going to do is this is where you put in a matrix into your calculator. You go underneath the edit tab. So push the enter button, and you should see this screen. If you already have a matrix entered in, it doesn't matter. You can overwrite it, okay? No big deal. So right now, the calculator's default is set to a 1 by 1 matrix, which means 1 row, 1 column, 1 entry, very boring. Okay? We want to enter in a 3 by 4. So here's what you do. You push 3, and you push enter, and then you push 4, and then you push enter. And notice the calculator builds for you a 3 by 4. It's very smart. Okay, now we have to put the individual entries into the calculator. So notice that it's giving me, look at this notation in the lower left-hand corner, ladies and gentlemen. It says A and then 1, comma 1. That means row 1, column 1. So what is the entry in row 1, column 1? It's a 3. So push 3 and then push enter. And notice it automatically advances you over to the next column, but stays in the same row. So my next one is a 1. So I'll push 1, enter. And then 2, enter. And then 31, enter. So go ahead right now and enter in all of these into your calculator. Okay, we've got everything entered in. Go ahead, double check mine, make sure that it's the same as yours. Do we look good here? 1, 3, 2. I need my glasses. 1, 1, 2, 19. 3, 1, 2, 31. Okay. Haha, funny joke. Okay. We all good. Now, watch this. You can now hit second quit. Second quit. Back to the home screen. Nothing going on, right? So sad. Here's the neat thing. The calculator has not deleted your matrix. Watch. When you go back into second matrix and you go over to the edit button, or actually you should see that there's a 3x4 now stored in my calculator. It's already there. It doesn't go away. So don't worry about deleting it. Sweet, right? You guys on board? Okay, great. Now I want to do some math with this matrix now that I have it in there. So the first thing I'm going to show you is how to do row echelon form. If you go over to the math tab, and you notice that option 1 is this DET thing, option 2 is this little t, option 3 is this dim, blah, blah, blah. If you scroll all the way down past what you can actually see on the screen, Tess, okay, past what you can see on the screen, and you scrolled all the way down to option A. Check it out. Option A has the letters R, E, F. What's that stand for? Row echelon form. So we're going to push enter when we're on option A. And notice it brings us right back to the home screen, but now we have ref in there for row echelon form. Okay, now the calculator is asking you for row echelon form of what? So the calculator is asking you for ref of what? Row echelon form of what? You have to tell the calculator of matrix A. That's the one that we entered. So go back and say second matrix, and the name is A, so it's already on A. So just push enter, and now you have asked the calculator for row echelon form for matrix A. You don't need to put the parenthesis on the end. You can if you want, but push enter just one time, please, and we should all see this screen. Okay? Okay, now there's some fractions in there, and all of you are the biggest fan of fractions. I mean, sorry, decimals, and you're not the biggest fan of decimals. So I can make this a little cleaner for you by doing this. If I go underneath from right here, notice that I've just entered in my one time. If I push the math button, I can change every decimal to a fraction. And then push enter because I'm already on the fraction option. And push enter again, and bam. Okay. So check this out. Let's have a discussion about this. Do you notice that now we have taken the matrix that was given to us, we put it in our calculator, and we have now turned it into REF form, which is row echelon form, right? So right now, what can I already observe? That Z is worth 5. And now I could use back substitution to go back and figure out Y and figure out X. Can I explain that? The back? Yeah. All right, hey, we can take this a step further. We can go even further with this, okay? So here's the second parlor trick I'm going to show you. Clear this all out. Actually, no, don't clear it out. Sorry. Leave it right there because I want to make a comparison. Leave this right here. Hit second matrix. Let's go back into our matrix folder. Second matrix. Go into the math tab. Okay? And scroll all the way down to REF, the one that we were just on, okay, which is option A. If you go one more, you'll see 2 R's and then EF, RREF. Now, this one right here, RREF, this thing is the golden nugget of matrices, all right? I'll tell you what I mean by that right now. So if we do RREF, by the way, the extra R stands for reduced row echelon form, okay? So if I hit enter, the calculator again is asking me for, hey, reduced row echelon form of what? And what are we going to tell the calculator? Matrix A. So second matrix, and then go back to, it's already in their name. Push enter, and now push enter again. Whoa. Golden nugget. Okay, why is this the golden nugget of all matrix problems? Because it gives you all the variables like Noah just said. Look, what's x worth? 5. What's a y worth? 3. And z is worth 5. Y is worth 3. X is worth 6. So the calculator reduced row echelon form, and you'll notice that I still have 1s in the main diagonal, but I also have that golden lower triangle and, in addition, a golden upper triangle. So when you have it in reduced row echelon form, you have essentially solved the system, because it tells you now, okay, 1z is worth 5, 1y is worth 3, and 1x is worth 6. So that is the answer to this system, and we solved it using calculator skills. Okay? Now for us, we need to be responsible to do how to get to row echelon form by hand and back substitute. You will also have to solve matrices using reduced row echelon form, but you can use the calculator. So I want you to have both sets of skills. You have to do both, okay? So tomorrow we're going to practice how to get things into row echelon form. I don't need to record all that, but